First of all, you notice I don't have the fancy OpenShift gear, you know, like the hoodie and stuff. That's because I don't work for OpenShift. Okay? I work in base OS. At Red Hat, I do the SELinux stuff. My history with OpenShift is, well, 4 years ago, I sat across the table from Mike McGrath, who's sort of the father of OpenShift, with him screaming at me that SELinux sucks. Okay? He's screaming, SELinux sucks, it's good for nothing, blah, blah, blah. 1 year later, he came to me and said, you know, we have this idea for a platform as a service thing. We need to use something to separate our gears and make sure that they're done. So we sat down at a Fedora conference about 3.5 years ago, and we hacked out the policy to basically allow OpenShift to run. So now Mike McGrath, I guess, has converted that SELinux no longer sucks. He kind of likes it. So that's sort of the history. A year later, we got together and wrote some more stuff for OpenShift. I actually monitor the OpenShift logs, the OpenShift online logs every day, and I'm going to show you what I go through. It takes me about 15 minutes to go through the logs, unless someone's doing something interesting, and I get more interested in it. So I'm going to show you a little bit of what's going on the logs on the machine. But we're going to talk about what this is. So first of all, anytime I do an SELinux talk, I want everybody to stand up. Stand up. Okay, I want everybody to read the top line. SELinux is a labeling system. Now we're going to read, everything has a label. Processes, files, directories, char files, block files, ports, nodes, all have labels. Everything is a label. SELinux policy defines rules that control access between process labels and other labels. Okay? The kernel controls those accesses. Kernel says the policy, follows the access. SELinux, that's it. Sit down. Now everybody's an expert on SELinux. Okay? Nothing more to it. Everybody thinks SELinux is black magic. The nice thing about that is everybody thinks I'm like this genius of SELinux. You know,
Can I see the outline for creating a policy? Is it more than just 3 points? That would be great.
I actually give between, I can do it in an hour, I can teach you how to write SELinux policy. I have a 2-day course, I teach SELinux policy, and I teach about a 5-day course in writing SELinux policy. So it's, you know, how much do you want? Okay. The problem with SELinux policy is it's like writing Perl code. Okay, everybody learns to do it 1,000 times. Okay, and then they forget all about it. So I'm going to talk about, let's talk about OpenShift, though, not so much about SELinux. But I'll talk about how SELinux works with OpenShift. Last year I went to Europe, sat in front of the French, showed them this slide. I went to the Germans, showed them this slide. Probably inappropriate for both groups. But SELinux is all about defining what your security goals are. Okay, so when you're writing policy for controlling an application, you define what your security goal is. How are you going to confine the application? How are you going to protect your system? Okay, I'm going to talk later about that, but if your security goals aren't very good, or don't implement it right, you end up with the marginal line. Next thing, SELinux is a type enforcement system. Okay, most things in SELinux talk about types. Okay, again, every process has a type, every file has a type. In an OpenShift world, the third field, everybody's seen this when they've seen SELinux, seen this incredibly ugly label. Okay, that is what an SELinux label looks like. The third field in there is the type field. So when we're talking about, most of the time when I'm talking about OpenShift, I'm going to be talking about the types. So if it's an OpenShift process, guess what it's called? OpenShift _T. The _T is just so we know it's a type field and not a role field or a user field. The other two fields in SELinux policy almost always don't matter, the first two. First one's a user field, the second one is a role field. Sometimes you're going to see your OpenShift instances running as system U, sometimes you're going to see them running as unconfined U if you started with unconfined process. That just tells you which SELinux user of the system started it. If it was started at boot time, it was started by the system, so a system user. It was started by a user that logged onto the system. Most likely that administrator is unconfined U, so it's going to be unconfined U1. The second one is the role. We're not really doing role-based access control at the SELinux level on an OpenShift instance, so it's almost always going to be system R, system_R. If If you notice, I pronounce the R with the proper Boston accent. So there's a tool called SEInfo to show types, and I just grabbed for OpenShift, and these are all the types that we define for OpenShift out there. But pretty much the one that almost everybody uses is OpenShift T. Now I'm going to talk a little bit more about types going on, but let me just tell you what types are. Okay, where SELinux is very revolutionary compared to other mandatory access control systems. Anybody ever hear of Trusted Solaris? Okay, Trusted Solaris is sort of the granddaddy of mandatory access control. Mandatory access control means that the processes don't have discretion over the security of their objects. Most of us use discretionary access control on our systems. Discretionary access control means ownership, read, write, execute, permission flags. Okay, that's what discretion, because a user of any owner of an object has the ability to loosen that object. And SELinux is controlled by the kernel and mandatory. Traditional mandatory access control with things like top secret and secret. And that's what Trusted Solaris was designed around. So in a Trusted Solaris type environment, it was looking at the level of the data. So if a process was going to look at top secret data, it would have to run a top secret. If it was going to look at secret data, it would run a secret. But it was more about the data, not about the actual type of the process that was working. SELinux is different in that it's a type enforcement system, so it's about the type of the process. So if you're an Apache process, you run as the Apache type. If you have Apache data, it's the Apache data type. If you have Apache read-writable data, it's the Apache read-writable data type. So if an application gets hacked, all right, you are allowed to do what an Apache process does. If you take over the Apache process, you are now an Apache process, and you're able to do what Apache process does. Doesn't matter what, if you're root or anything else. I'm going to show you that in a minute. An actual demo of what happens when OpenShift T runs as root. But basically, so it's a type enforcement system. So if you're an Apache type and you try to read database type, and the rules don't say you're allowed to read it, you're not going to be allowed to read it. Doesn't matter what the ownership flags or anything else are. That's what makes SELinux tend to be difficult, is people tend to move their data all over the place. Okay, so when I move my data all over the place and I forget about SELinux, all of a sudden my Apache data gets put into a random directory, or it's user data, or that gets moved to Apache data, Apache directory, and all of a sudden Apache data is trying to read user data. No, it's not allowed, so you have to fix the label. Okay, so that's a quick overview, but we're talking about types here. Now, the interesting thing with the OpenShift type is we can define the rules that are allowed for the OpenShift type. And when I'm saying OpenShift type, this matches up to what we were talking about gears, or I guess applications. I think in terms of gears, just the user ID process running on the system. I guess you guys are calling those applications. Applications are, I don't know, these terms. So basically, when a user application is running, or the user is SSH into the box, what label is associated with him? Almost always in an OpenShift environment, that is OpenShift_T. Now we actually have different rules. We have different rules about the types. So in a standard OpenShift, we have different rules from hosted to what's in Origin. Okay? The reason we have different rules of hosted versus Origin is we're trying to really control what those users are able to do in the system. So we have a slightly tighter control over those processes. In Origin, we're allowing them to use full network. In hosted, we're controlling the network. The big thing we're worried about in hosted is around mail, sending email. We really don't want OpenShift to become the biggest mail spam bot on the planet. And trust me, they're trying to do that. They're trying to put porn into it, they're trying to put spam bots into it. And we're trying to block them. Yeah, so there is a slightly different policy for OpenShift hosted, although 90% of the stuff is all in Origin. And all we do is shut off the Origin policy and turn on this. But if you did a listing of the modules in RHEL 6 or current Fedora, you'll see OpenShift policy. So I see module-L, you grab for OpenShift, you'll see it. So process labels cannot be put on files, and file labels can be not put on processes. There's another thing about SELinux, people get confused. I'm running the Apache, it says it's HTTPD_T. I want it to be able to read data on the system. I tried to put the HTTPD_T object on the system, and SELinux says not allowed. So the main thing here is that process labels and file labels have to be different, and we define that in policy. So when we're talking about the process that's running inside of an OpenShift instance is OpenShift T. The data happens to be stored in live OpenShift. So we ended up calling it OpenShift FileLiveT. OpenShift T is able to do anything it wants with any file that's labeled OpenShift FileLiveT. Okay, so if you have a process running on the system, OpenShift T is able to do anything it wants with OpenShift FileLiveT. If that same process tries to write to Etsy Shadow, Shadow is labeled Shadow T, it's going to be blocked. So that's what type enforcement is. The problem with type enforcement is that I said OpenShift T can write to OpenShift FileLiveT. Every single gear is going to be logging in as OpenShift T. So if I'm OpenShift T and Krishna is OpenShift T, he can write to my data and I can write to his from an SELinux point of view. Okay, so SELinux, if we just went with pure type enforcement, it doesn't give us the separation we want. I mean, we want to basically say an OpenShift instance is only able to connect to these ports, not able to read certain critical data on the system. What we really want to say is OpenShift T are each individual one separated from each other. So we take advantage of this last part of the SELinux label. It's called the MCS label. It was designed for those MLS people. So when we go back and talk quickly about MLS, top secret, secret. This is where on an MLS system in SELinux, we put the top secret and secret flags. On a targeted system, which is the way most of us run SELinux, and I'm sure you all have SELinux turned on your machines, because if you didn't, you know that SELinux was developed by the National Security Agency. It was developed by the National Security Agency in order to improve the security of the United States and our allies. So if you disable SELinux on your system, you are being unpatriotic. Okay? Just wanted to get that out. Okay, so when we talk about SELinux, the last field here, in a traditional system, say a RHEL 5 box, that's always S0. Totally ignored. As a matter of fact, we even turned it off so you wouldn't even see it on. When RHEL 5 was being developed, we came up with the idea of this multi-category system. And when we talk about MLS levels, there's sort of two fields here, just to quickly go over. S0, this goes from S0 to S15 on an MLS system, meaning secret, unclassified to top secret. You put in the levels, and then I had this idea of categories, so you could say things like, I am top secret British intelligence, Australian intelligence, or I can be top secret French intelligence, US intelligence. So you could have categories of top secretness. Anyways, none of that stuff means anything in the real world. All right, so what we decided to do when we were working on secure virtualization is to take advantage of that field, because even in a secure virtualization, every single VM, KVM, every single VM we launch runs as S-VIRT. And we define what it means to be a virtual machine. And we define what it means to be a virtual image, but we wanted every virtual machine to only be able to read and write its image. So what we decided to do is just pick a random one of these labels here, the categories, and assign it at startup. So as soon as the process starts up, we take the MCS label associated with the process, we associate it with the image, and we run. That is called MCS separation. Okay, we invented it for, actually eventually for virtualization. When we came to look at doing OpenShift, we said that's a good idea, why don't we do the same type of thing? So what actually happens is when you start up an OpenShift instance, every single OpenShift instance has a unique MCS category associated with it. I'm going to show you the algorithm that unique MCS category is actually related to the UID. So we actually, in secure virtualization, we actually pick them randomly. In OpenShift, we actually assign them based on the UID that gets assigned to the user. And since the UID is unique, the MCS labels could be unique. You see here, we have OpenShift T running C1, C2. It's able to use this. And this one's running C3, C4. It's able to do this. If this guy tries to do that, SELinux is going to block it. They have to be the same. And since I'm such a graphics artist, I put together a little picture of what happens in this. So basically, you have two OpenShift instances. OpenShift, I had a better one of this. This is supposed to be over here because it's trying to get to his data, and the kernel's going to block it. Here's the algorithm to translate a UID into an MCS label. Interesting, the MCS label, we only pick out two. The reason we pick out 2 MCS labels go from 0 to 1024. So you actually have a combination of 0 to 1024 times 0 to 1024. Anyway, the math comes out to be there are 500,000 MCS labels available. So when we get to 500,000 users on a OpenShift, we might have to actually increase that. We used to laugh about this back in the day when we were doing secure virtualization. We said no one's ever going to run 500,000 virtual machines on one box at the same time. Well, we might have been mistaken. But we can go to a 3rd and 4th and continue to get up to multiply. So that theoretically, you could have 1024 categories on a single process. So anybody that's a math major can quickly understand what's going on here, but some math major figured out a way so that we can translate these all the time. Some modding going on there. So how do these labels get on gears? Well, basically, there's 2 ways that gears can get instantiated. And I might be lying here because I really don't know any higher level than what I am, which is sort of, I always think to the guys in the Titanic when it's going over, they're shoveling the coal into the, yeah, I'm the guy shoveling the coal. I really don't know what's going on above the coal room of the OpenShift, okay? But basically, when a packet arrives at the host has the ability either to know that the gear is currently running or it's going to kick off the gear. He didn't mention that it uses a tool, I believe it uses a tool called OddJob to actually kick off the gear. I know that. But basically the gear gets kicked off, and there's all sorts of scripting inside of the tool there, just bash scripts that are basically going to say, run the gear, has this UID, get the correct MCS label to it, and start it up. And I'm going to show you exactly how to do that. You could all do it on your Fedora or RHEL boxes right now. And then it takes the packet, launches the application, correct SELinux label, sends the package to the application. The other way you can get to a gear is you actually can SSH into the box. One of the really nice things about SELinux versus every other, I believe every other competitor of OpenShift, is that they give you trimmed down tools, right? They give you tools that are stripped of their functionality, like you get a less powerful PHP, or you get a less powerful version of Perl, and what they're trying to do is they don't want you to get an SSH into the box. Because the number one thing, anybody that's followed security, there's 2 types of exploits that people always talk about. There's remote exploit and there's local exploit. Anybody ever hear of that term? Sure. And when you talk about that term, everybody always worries about remote exploits, right? That's the remote exploit is the biggest problem. Well, on OpenShift.com, every exploit is local, right? Because you can get an SSH into the box. So you have, and anybody can get that account. Anybody, North Korea and South Korea can get an account. I always do Coke and Pepsi, But anybody can get an account on there, and we're giving you, hey, come on in. And the reason we're doing that is because we're using mandatory controls in SELinux to control what you're doing. So we're not, but the main idea there is that you get full regular Ruby that's available on RHEL or Fedora. You get the full PHP, you get the full MySQL. Every application is the exact same thing if you did a yum install in your local box. So when you SSH in, we actually have a special PAM module called PAM OpenShift. And all PAM OpenShift does is that exact algorithm figures out the MCS label and then launches SELinux to say you're logging in as OpenShift _T, MCS label. Launches the shell. If you go in with Git, it does the same thing. I believe Git goes through the it goes through SSH protocol also, so it's doing the same thing. So everything that happens to that gear, as the administrator of the gear, is running as the same SELinux label, same MCS label. Everybody got it? Yeah. Want to see a little demo? So what's the number one thing you want to get if you're a hacker of a Linux system? Root. Root. Okay, let's take a look at root. Okay, so here I am as root, and I'm about to run the shell. Okay, so if you look here, all I did is a standard SELinux command that's available, run con. I set to run as systemr OpenShift T S0:C1, C2. So now if I looked at what my process is running at, you'll see that it's running with this label. But I am still root. right? So here I am. I have hacked through every type of security that we put into the system. I've hacked through RHEL. I've gone into the root process. Right? I should own the host at this point. So I should be able to create a file in root, permission denied. Cat Etsy shadow, permission denied. Ooh.
Uh-oh.
Actually, I'll explain what's going on there. Actually,
That's a feature.
I should test it. It's a feature.
Yeah.
Actually, I was requested, ping used to be denied in a previous version. And what is being denied is all OpenShift instances can't get raw IP sockets, because we don't want you watching some other gear's traffic. So we blocked the ability to execute ping originally, and people complained, because everybody kind of figure out what's going on to diagnose it. So with SELinux, actually, when I'm running ping, is what's called a transition. Not really important, other than it's a sort of advanced SELinux concept. So the only tool that can open up a raw IP socket is ping. So I shouldn't do that as a demo, because it just ruined my demo, ruined my flow. So I could do an RM of SE password. Okay, I get a little nervous when I do this, because you want to make sure that it's
RF.
So SELinux is totally enforcement. So what I'm showing there is basically that OpenShift instance is only able to do what an OpenShift instance is designed to do. So if you looked at what an OpenShift instance is designed to do, it's able to write to OpenShift via libT with the correct MCS label. So I don't have one on here, but if I had, it would be only if the MCS label OpenShift via libT is S0C1, comma 2. Do you have a question? Okay, so that's basically where the SELinux controls come in. When people talk about other technologies, they don't have that technology. That's one of the reasons we require SELinux in this thing, is because we can provide this type of control, even if you get to root. Okay, so I mentioned earlier, I monitor the logs on a daily basis, and
Yeah.
yep.
What can root do that a normal user cannot do?
Nothing. All right. SELinux does not understand root.
Okay.
So this is, root is just nothing to SELinux.
All right, thanks.
I mean, SELinux has no idea what UIDs are. SELinux is a parallel stack to what, SELinux is sort of a parallel stack to what the just normal discretionary access control, ownership, root, stuff like that. So you have to actually get through both to do these. Now, every day, as I said, I generate a report that I send to the security analysts that looks something like this. By the way, now keep this under your hats, but I get logs from well over 200 virtual machines running an OpenShift instance, running thousands or hundreds of thousands of users. Okay, so they generate a lot of SELinux traffic. So I've built some tools to actually look at what's going on here, and these show the ports and stuff like that that they're trying to connect to. The people that made the decisions on which network ports should be allowed and which ones aren't is not me. So if your favorite port is not able to connect, you can't go home and stick voodoo doll pins into meat, it's something that's wearing, It was all decided. The real problem with those decisions on which ports are open, there is nobody that's necessarily, so there's no security guru out there saying, hey, connecting to port 87 is better than connecting to port 86. Okay? There are some ports. Any port less than 1024 we're going to handle a little bit differently. Everybody know why ports less than 1024 are important?
They're well-known.
Well-known ports, right?
Yeah.
You have to look like this guy or me to understand why that is.
Yeah.
Back in the 1970s, when there were 12 computers in the world all running at different universities, if you could bind to a port less than 1024, you were trusted. If you bind to something less, you could be a hacker. Since there were only 12 computers in the entire world, that made sense, right? Because only you'd have to be a real good administrator to get root on the machine. So less than 1024 is a trusted port. And obviously it shouldn't be at this point, but it is. So really at ports under 1024 we try to control. But there's other ports that we look at randomly. But basically people try to connect to ports, and you see things like this go on. When someone goes, a lot of people get on there and say, I want to find out what port I'm going to connect to. So they write a for loop and go connect, or, bind, and try all the ports, and that's how they get it. So you see stuff that looks like this. But if your favorite port is blocked, make a big stink about it, and maybe someone will open it up. In OpenShift Origin, we're not blocking ports. You can connect and bind to anything you want. So this is sort of, these reports, this is the part of the stuff I ignore. So I just have the tool go out, and probably people ignore it on the real world. Although I do see things like this, which trigger SELinux fixes in my mind. So when I look at this stuff, I'm not necessarily looking totally for hackers in OpenShift world, but what I'm looking for is things that SELinux is blocking that it really shouldn't block. So a lot of good ideas come out of this, because I get to watch 100,000 people work with SELinux. So the second part of this is my curious list, and that's what this one, actually you see this one showed up in the same one. So these are the ones that I take special interest in. So I'm looking for things like, an OpenShift instance trying to write to the system's HTTP config file, or reading a default key. This means it's a file underneath a separate directory. And usually most of these problems are actually caused by these guys. The administrator's screwing up. Okay, so when people say that things like, SELinux is, tough to deal with, the problem is these guys regularly make mistakes that end up leaking into applications, not just any administrator, right? Administrators are going to screw up, we're humans. So when they screw up, I see things like, leaked file descriptor. Everybody know what a leaked file descriptor is? All right, one guy in the room knows a leaked file descriptor. How many of you guys are programmers? Okay, if I write a piece of code that says FD equals open etc password, and then I do fork and exec to a new program, does that new program now have an open file descriptor to etc password?
Yeah.
Right. One person said yes. Everybody else agree with him? Does it? The answer is yes. If the init program opens up a file descriptor to a program, and then does a fork and an exec and a fork and exec and fork and exec and fork and exec and fork and exec and fork and exec, does every one of those processes have an open file descriptor to the original program? Yes. Right? That means that anybody can read and write to that object because it's been opened. The kernel does not check access after the open, unless you're using SELinux. Okay? So what happens when these guys screw up is they do things like opening up a program, and then they're writing these really complicated scripts, and they end up leaking file descriptors into those OpenShift instances. So you see things like that happen all the time. Of course, I don't have one that's showing up right now, but so I send them instances like that. Here we have a default T. Default T means they created a new object on the system in the / directory, and we're not able to read it. So I have to contact them and say, what is this default T? You guys got to tell me what your content is so I can label it correctly. Once in a while, I see people doing evil things. I've seen rm/rf of /. I've seen people try to do lots and lots of stuff. The problem is it's hard for me to tell when you're doing evil or just probing. Because everybody gets on this thing, and the first thing they do is they do sudo, sudo, sudo. They run all these setuid applications. So one of the things I've had the OpenShift hosted do is to take away world executable rights on setuid applications, and basically, so a lot of the applications in hosted are like sudo is 750, and then they have a group of administrators that log on to them, and they can actually run the sudo command. And it's not for security purposes, because SELinux would very well block it. It's just that there's so much noise from everybody getting on there. Oh, let me try to hack it. And everybody does that, or find /. Oh, what's on here, or that type of thing. And it's really hard to tell, but you know, sometimes you do see people doing stuff. And we do block things like relays and stuff like that. So that's sort of monitoring logs. I think for the most part, you guys can just ignore the logs, right? Everybody's, you're not going to go through those logs, but you know, that's what's happening. Yep.
So these are all the things that you're seeing that are happening when people are doing things. But in terms of a normal user of OpenShift,
Normal user of
They don't
OpenShift,
need
those
to
100,000 people have no idea SELinux is doing
and they
anything.
never need to.
Right, they don't need to. The reason they don't need to is because they are in I don't want to say the word container because there's no such thing as containers, but they're in a world where they're allowed to do everything they want. The only thing they would ever see in a hosted environment is perhaps they're not able to bind to certain nodes or bind to certain ports or 127.0.0.1. So then probably the number one problem I have here is that people trying to bind to 127.0.0.1 because they forget the rules to bind to your, and I'm going to talk about that in a second. Am I running way over or am I doing it good? Okay, but for the most part they don't, you know, they're allowed to write to their directory, they're able to read to their directory, and you know, most of those people that are running these applications are just able to run their applications. So here, let's turn the film off right now, okay? I'm going to talk about the problems in OpenShift security. Turn off the... So one of the problems that inside of a gear or inside of these container environments, it's like Las Vegas, right? What goes on in Vegas stays in Vegas. The main goal here is to stop Vegas from causing trouble in Portland. We're going to get these out of it. But basically, we're not really concerned about what you're doing inside of your gear. I don't give a crap. You write bad code, you're hacked, I don't care. As long as OpenShift doesn't get hacked, what difference does it make, okay? So when you're running any one of these PaaS servers, I believe in, I mean, I don't know how everybody else runs it, but they're all using UID separation. Your application, the administrator, are using the same UID. The application, the administrator, are using the same SELinux labels. So if your application sucks and it gets hacked, you're hacked. But the reason for that is the app and the instance are running the same thing. So if you're doing a Git check-in, that's the same everything. All security related Git check-in is the same thing as the person coming in and running packets through your Apache server. We have built policy to differentiate between the two. So there is an OpenShift T and there's an OpenShift App T. So the OpenShift T is an administrator of the gear. OpenShift App T is the type of the application. OpenShift File Live T is sort of the general application. Then there's an OpenShift Read-Writable File T that basically says that the application is able to write to this type. So we have the functionality to do this in OpenShift. We haven't turned on any of this. The real problem here is we don't want users to understand what I just said. Matter of fact, most of you guys are sitting there saying, what the hell did he just say? Really what a user wants to say is, I want this directory to contain my data. The data of the application. And then the rest of it would just be this general label. So we really need a mechanism to say whether or not you want to have that separation. So we could separate an application in such a way that the Apache service running on your box is running as application app T and is only able to write to your data directory. They're able to execute everything else and read everything else, but the administrator coming in could only manage the data. And then we could get some limited separation between the application and the administrator.
So is this policy in the origin?
Yes.
And
Not turned on by anything.
what does it take to turn it on?
It takes someone to understand something higher than the boiler room that I'm in. Okay, it's basically a runcon command, so separating out the OpenShift PIM instance from the thing that's launching the application. So you can basically, if you go in and you know, it's sort of where we want to start. If people are interested in hacking OpenShift, you know, they're just shell scripts. And if you look at the shell script, you'll see something that says runcon OpenShift T, the exact command I executed. And you can change that to OpenShift app T. But it'd be really cool to take it to another level to allow individual gears to run with different SELinux policies, different SELinux types. So in OpenShift policy right now, there's OpenShift T and OpenShift app T. On Origin, those are basically full networking. On hosted, they're limited, they're blocking some network ports. But I've also defined 2 other policies. So there's OpenShift Min-T, which gets no network. So basically, you just say you're an Apache server, say you're a restaurant serving up a menu to your customer, and all you want to do is come in and look at the menu, right? So you want your applications to come in, look at the menu, and that's it. And everybody else get out. So you could run that application with the minimum policy that basically has no network ability, no ability to send data off the machine. It's just an Apache server that's read-only. And then OpenShift NetApp-T, which is full networking access. But you get to do everything in between. It's fairly easy, at least for me, to write policy to take OpenShift Min-T and create it into OpenShift Min-T with port 80, or OpenShift Min-T with some random set of ports.
Is this part of why we can't share databases? Is this what we would
Can't share what?
share databases between applications?
Well, the reason you
No.
can't, well, I got to talk about that in a second, but so this is sort of, I mean, we could talk about why that happens, but really, one of the goals with sort of the next version of OpenShift is to get trust between the nodes. Okay, and what we really want to do is we want to say, right now, we're saying they're sending up these distributed applications. If every application had the same UID, so if you had an application, OpenShift should be registering a single UID. So if that user now says, I need another gear, he gets another gear on a node with the same UID. The problem is we've been sloppy up till now. Not pointing any fingers.
Wouldn't that limit you to the 500,000 across all nodes then?
We have what are called districts, districts of nodes that fix that.
There's 4 billion used UIDs, so I don't know why you're getting.
Oh, I said earlier, the way
The MCS labeling.
the way you were
The
creating
MCS labeling, yes, that would limit us to 500,000, but we can fix the MCS labeling.
Okay.
It's just a matter of having the 3rd category.
Okay.
It's just, we haven't hit that yet, so it's still going to go on. But the problem right now is it's difficult. It's the same problem NFS has had for 40 years, right? It's difficult to maintain UIDs, the same UIDs across the infrastructure. But if we got the UIDs to be the same across the infrastructure, then we could start to look at how we can build trust relationship between the nodes. All right, so what I really want to block here is I want node 1, gear 1 not to be able to attack node 1, gear 2, that's what we currently block. We want to get to the point where node 1, gear 1 can attack node 2, gear 2 if we open up so the trust relationship currently between them. The way we do this with an advanced thing in SELinux called label networking between nodes. And it's based on this thing at SIPSO. Anybody here ever hear of SIPSO labeling? No. Okay, SIPSO labeling is again, it's used for MLS capabilities, but we've actually sent out some notes to the internal OpenShift developers saying we have some ideas on how we could do this. And then you can start to build up the trust relationship between nodes and allow people to do sort of distributed databases and have trust to say that this guy can come in, this other guy. So basically that's a little bit about label networking. That's something else we want to work on in the future. So a big problem with SELinux confinement is node separation. So on a node, I have multiple gears, and this is why 127.0.0.1 is blocked to everybody. Okay, everybody wants to bind to 127.0.0.1 because everybody thinks they own the machine, right? And the problem is, as soon as somebody binds to 127.0.0.1 8080, someone else is going to come in and try to bind to that, and the system's going to say that's already taken. So what we really want to do is make sure that everybody's sort of isolated from each other. And what we did with SELinux when we first wrote this is we basically took away 127.0.0.1 from everybody. Just because, why should one person, the first one, get the glory? And everybody has to use these other random 127 nodes. And when I say nodes, I mean something different. I'm talking SELinux nodes versus, so I shouldn't say that. Basically, you get a range of IP addresses in the local host range, 127.1.5.32 through 37. And that's an environmental variable you're supposed to use in your application to bind. Everybody forgets to do that, SELinux blocks it, they get mad. So that's one big problem we have right now with OpenShift. A second one is SELinux, from applications try to do SELinux stuff. Yes? Go ahead.
If that's such, I mean, there's so much inter-process communication that happens through the loopback. Is that what you're talking about? That's the loopbacking.
Yes.
So why couldn't you just, from the kernel, use 127.0.0.1 as an alias for whatever environment variable you're referring to?
It's special. Let me get, they're going to talk about what's going to happen in OpenShift version 2. So that problem's going to be handled
Okay.
by containers.
Okay, I was gonna say, why don't you
Yeah,
use
namespace.
Linux bridging to get around that?
I'm
Just like,
shoveling coal.
okay, you're not doing LXC containers, but LXC containers
No.
are just C
There's
groups,
no-
Linux bridging.
Let me finish. Let's finish the talk. There's no such thing as LXC container. Okay.
The product called LXC container.
There's no
is
product
just
called
C
LXC.
groups.
There's a tool set that was developed by IBM called LXC.
It's the C groups, Linux bridging, and Chroot, and a little bit of magic cooked in. You're already using
All right,
C
I'm going
groups.
to show you exactly what's going to happen using namespacing, which is the kernel's implementation of network namespacing. I'm going to talk about, there's some shortcomings of what's in RHEL 6 that's now in Fedora, and I'll show you, that's the end of my demo. You're supposed to hold off on it. So I'm going to show you that in a second. Secondarily, apps try to do SELinux stuff. I see lots of apps, not anybody writing code that does SELinux, but they use VI, Emacs, things like that. Those tools all understand SELinux. So those tools try to do SELinux things, and they generate ABCs. And the problem is that, again, what's in Vegas shouldn't know that SELinux is enabled. So I really want to basically tell all the applications that SELinux is disabled, don't try to do any SELinux stuff. Because at least then I would know if they're trying to do SELinux stuff and be evil, I could look at that. Lastly, in OpenShift right now, SELinux is blocking access to other processes. So when you do a PS command, or if you do an ls/proc, you're going to see a lot of permission denied, but you're going to know that there are other processes running in the system. So the way I want to block all this stuff is by taking advantage of namespacing. Namespacing is what most people think of as LXC containers. Okay, that's where it goes to. So we're going to show that in a second. Secure Linux containers. Okay, so in Fedora 18/19, we're still developing, still under heavy development, we're adding the concept of Linux containers. Actually, this is a real product, and you can buy Unixware containers. People send me these photos all the time. So what Linux containers are, even though there's no such thing, is actually, the next slide explains a little bit. But what containers do, really the concept is a thing called namespaces. Anybody ever hear of PAM namespace? Okay, PAM namespace has been around since RHEL 5, Fedora 6, Fedora 5. What PAM namespace allows you to do is to run a process with a different mount table or different mounts than its parent process. So when I do namespacing, what I'm trying to do with namespacing is basically saying, I'm 16 years old, I don't want to listen to my parents anymore, and everything I do from this point on, my parents aren't going to see. So it's a process that's able to split from his parent and then start doing stuff that the parent no longer sees. So what you want to be able to do is basically say, I want my own /temp. So when I'm using PAM namespace, what happens is the login program comes in, fires off PAM namespace. PAM namespace tells the kernel, this process from now on, its mounts are not going to be seen by the parent. So the next step is going to go mount a different tempfs or a different directory on top of /temp, and from that point on, he has a different /temp than his parent does, or he has a different home directory than his parent does. So right now in OpenShift, we're actually using namespaces, PAM namespace, to do exactly that. So every single OpenShift instance has its own /temp, its own /temp, its own dev share mem, which are read-writable places that people expect applications to be able to write to. But we don't want North Korea and South Korea to see the same /temp. We don't want them to be able to screw around with each other. So when these gears start up, they actually get their own /temps. taking advantage of a thing called namespaces. Namespaces, there's a tool developed for namespaces called LXC, developed by IBM to take advantage of kernel namespaces. So most people equate LXC with containers with namespaces. So I'm about to show you what the namespaces are. The problem is containers are not security. So when the competitors against OpenShift are always coming out and say, we have containers, we don't need SELinux.
Oh.
Okay? And that's the number one argument by the competitors against it. The problem is containers is not security. I should make everybody stand up right now and say containers is not security. Okay? The problem is that the entire Linux operating system is not containerized. So if you get a privilege escalation and you get to root, you own the system. If you get a local privilege escalation, the machine's owned. If you're running as root, the machine is owned. Containers has no way of blocking that. Things like SELinux are not containerized. Audit subsystems not containerized. C groups not containerized. The ability to create device nodes not containerized. The ability to talk to anything under /sys not containerized. So there is no control based on containers to basically control it. Containers just came out with UID separation. You know how long it took a hacker to figure out how to crack UID separation? The first major hack was within 1 week. Okay, so the whole idea of containers. Containerization, or SELinux containers has, I believe, or at least they state that they have this full containerized separation. But what SELinux containers have is closer to what we have with KVM. So containerization is not a holy grail. But what I'd like to do is I'd like to take advantage of more containerization, or more namespaces inside of Linux to solve some of our basic problems. So let's get into namespaces. So namespaces, right? First one I talked about is a mount namespace been used forever, since Fedora 6. Matter of fact, this entire presentation, anybody ever here use Sandbox on the Fedora box? Everybody that uses Fedora, I know you're best that we already covered that SELinux is enabled. Install sandboxes and run the tool sandbox and play around. Sandbox-X. This entire presentation is done inside of a sandbox. But basically what it does is has OpenShift, this one's OpenOffice, or LibreOffice, is totally containerized inside of my application, inside of my desktop. So OpenOffice is not able to screw around with my desktop. But that's taking advantage of mount namespace. There's another namespace called UTS. What UTS allows you to do, it's not very powerful, but basically you can have different host names on a box. So if I say host name inside of my container environment, I could have a different name than the host name on the real node. IPC, this one's kind of neat because it basically allows you to have shared memory segments that are separated. So if I go on and create a semaphore, I go on and create different things in /sys that can be containerized or separated. This one's huge, networking. This solves the local host problem. Okay, so and I'm going to show you a demo of this. This is a critical to fix the local host problems to turn on networking namespacing. The network name?
The IP NetNS stuff or IP NetNS?
Yes, it's the NetNS stuff. Basically, what it allows you to do is have an entire IP stack that is different than your parent. Now, we don't have to take advantage of that entire IP stack. And the first is, as soon as you turn it on, though, you instantaneously get your own local host. But you can also get your own E0. You can set up a full IP table stack. You can do all sorts of really fancy stuff that I don't think will ever turn on an OpenShift hosted. All right, but maybe OpenShift Origin and we will turn on OpenShift hosted because customers are going to want it, but we won't turn it on. Screw up the terms. OpenShift hosted is the OpenShift.com. So OpenShift.com can take care of local host separation, but maybe Origin might want to set up, say, IP tables rules that says your application is able to bind to the certain network port, but only these hosts on these IP addresses are able to connect to it. So you could set up full IP tables rules based on this stuff. Hidden namespace, very cool. Basically, you can have your own set of processes. You lose the view of all processes on the system. You get your own PID 1. And the last one is UID. Right now, I'm not a big fan of UID just because I believe that there's so many bugs and there's so much assumptions around UIDs that I have a feeling that it's very broken. So right now, we're not turning that on. So the tools that we use inside of Red Hat and Fedora right now to launch containers, or launch the concept of containers, is a thing called libvirt LXC. I think it's very unfortunate that they chose the name LXC to go on there because it continues to perpetuate what LXC is. But basically, there's a tool, libvirt now has full capabilities of launching those 6 namespaces. What this libvirt LXC do is boot in an init binary, or an init program, or a bash shell, whatever. It will launch it with SELinux types, so you can tell it to launch with particular types and particular MCS labels. You can set up pass-through bind mounts. You can set up all sorts of different mounts into your container environment. You can set up firewalls, you can table rules. You can set up C groups wrappers on it, so you can actually do all the stuff OpenShift's doing right now on its own, but you can start to use libvirt as a central central controller of it. It's available in 6.4, but you're really on your own. So it's very primitive what's in RHEL 6 at this point, but there's really some nice tools coming along in RHEL 5, and Fedora and RHEL 7. So the tool that we build on top of libvirt LXC is this tool called Virt Sandbox. So if you'll go on and look at Virt Sandbox, that's a tool that actually allows you to create these things fairly easily. And I'm about to show you how we can create one. So I've actually built a helper application called OpenShift Sandbox. And I'm going to say I'm going to use UID 3267. That's why you don't. That's why I should have a videotape for this.
What RPMs did you have to install to get OpenShift Sandbox?
That doesn't exist.
Oh, okay.
Virt Sandbox is the tool I can do that actually. Let's do that. I don't know what I was doing wrong before, but okay.
Create keyword was missing.
Is that what I was missing? Yeah. Okay.
So the OpenShift Sandbox, like an alias or something?
It's actually a shell script that I'm going to give to OpenShift.
Oh, cool.
I mean, it's a Python script. I write everything in Python.
Good.
I'm really ignorant of C at this point because I'm too old. I think you get to a certain point, I don't want to deal with memory anymore. So. It's programmer Alzheimer's. Get away from managing memory. So what I'm going to do here is I'm going to start up. Anybody know what just happened?
You're still running that shell under the runtime.
Right, so I'm running that. I just tried to communicate with OpenShift to create a container while I was running as OpenShift T, and of course I'm blind. So you got to be a little bit careful with this stuff. So here, I'm just going to kick off a container. So I got to container running is OpenShift 1. And what I can do now is actually, this is something you can't do in RHEL 7 or RHEL 6. I can actually launch I can actually launch processes from outside of the container into the container. All right. And so what I just did here is I said I want to, first sandbox is the tool I'm using to execute OpenShift 1, but I'm just going to execute bin shell and then assign to the container. So I just did that, and now I'm inside of the container. And if I do a get enforce, SELinux is disabled. Now everybody's out there twittering right now. Dan Walsh says inside the container you should disable SELinux. Do you think I would ever unpatriotic enough to run without SELinux? Come on now. All we're doing is lying. Okay, so inside the container we're lying. Nah, SELinux is disabled. Go do whatever you want. Okay. So what's happened here is actually live SELinux now looks at the stuff that it usually looks at to see if SELinux is enabled. If it's read-only, it comes back and says SELinux is disabled, so we're lying to the thing. The beauty of this is we stop the containers from being able to do SELinux. We don't stop them from doing SELinux stuff, but we stop them from accidentally trying to do SELinux stuff. So inside of the container now, SELinux is disabled. If I did a PSEZ, inside the container, the only process I'm seeing, look what PID 1 is. It's not an init, it's running libvirt sandbox. When I set it up, I told it to run its init program as being fake Apache. I don't actually have OpenShift installed in this box because installing OpenShift on your laptop, not a good idea. Okay, I've tried it. It does some wacky stuff that you really don't want to be an OpenShift node and a laptop at the same time. So anyways, I just sort of faking out what an OpenShift gear would look like. So all fake Apache is doing is using netcat and C to bind localhost to port 8080. Okay? And then it's rewriting and it's sending back data to me. So if I start up, so the interesting thing here is now, instead of executing this, I can run MC. And it comes back and says, I'm running 3267, OpenShift 1, and it's saying hello. So I've just proved that inside of this OpenShift instance now, it's bound to 127.0.0.1. Ooh. Okay, so all I've proven there is somebody can bind to 127.0.0.1. So what we want to do here is we want to start up another sandbox. Did I create OpenShift 2?
You did.
Yes.
Are you still inside the first
No, I
sandbox?
got out. Okay, so now I have OpenShift instance 2 running. And just to prove that there's nothing up my sleeves. Oh! Ignore that. I can start it up again, but what's happening, I think my script exits after you connect to one time. Anyways, the idea is that you can have multiple people binding 127.0.0.1. So it actually fixes two of the big problems. Remember that slide I said these are the big problems. So getting to the point where we take advantage of namespacing, at least the network namespacing, the PID namespacing. So now inside of one of these containers, see there's only 4 PIDs running. If I go back to the, seems to have a bad habit of not running that. So on a standard, but basically on a regular OpenShift, you see these type of things, which are basically saying these, you're blocked from seeing it, but you actually somewhat see it. So it's kind of, SELinux is blocking you from really getting in and looking at it, but you can actually understand this process running. So taking advantage of namespaces plus SELinux gives you the security, better manageability, better, and it fixes some of the problems. The real nice thing is when I was actually entering the containers, all that stuff can happen from Apache. So the Apache server on there can enter a namespace and send the packet in, and you can start taking it back. That's it. Any questions? I do 1 hour? Yes.
So if your real security comes from the labels and the pipes, and you don't really trust the user, what do we call it, the user?
I don't trust users. I don't trust humans. Period.
Do you think really the only purpose of having user ID, like properties on files, would be like just to keep?
Yeah, I don't like to turn off any security. Okay, so it's, you always want, I can screw up with SELinux. Okay, so SELinux policy can be screwed up. So you want UIDs, you want SELinux, you want to take advantage of these namespaces, you want firewall rules, you want, it's basically all, if you ever went to West Berlin and watched the layers of the ways they try to stop people from escaping East Berlin. It's like that. You just want layer after layer of protections. So, yeah, I want UID separation. I want everything. The whole, everybody hear of SE Android? SE Android. It's basically been developed by the NSA developers. They're taking advantage of some of the same technology. They're actually using the MCS separation for individual applications. In a regular Android operating system, which I of course have on my phone, every application is separated by UID. That means that if your banking application screws up and writes your credit card data as world readable, every application on the box can read it. So relying on UID separation is just insane. Right, so that basically means that's why I'll never do online banking on a phone, at least not until I get an SE Android phone maybe. SE Android is basically taking advantage of similar technologies, very similar technologies. Lastly, if you want to see what a sandbox looks like. So this is Sandbox Xterm. So here I am as ID dwalsh, ID dwalsh, nothing in /temp, lots of stuff in /temp. Home directory's got only 1 file. Home directory's got thousands of files. So sandboxing, this is another form of sandboxing, this is desktop sandboxing. Also using very similar technology. If you look up here, MCS separation. All right, so everything comes down to, I had found one hammer 5 years ago, and I've been just hammering, like a hammer in the morning. Bad old jokes, but basically, so sandboxing is another version of MCS separation. Every application is basically allowed to do anything it wants in its desktop, but it's not allowed to touch the rest of the desktop, so that's what Sandbox X is. Every PDF, every open office document I download to my machine runs inside one of these sandboxes, so I don't have to worry about being attacked by looking at random content on the internet. So all PDFs, all open harness. Any other questions? Yeah.
Do you sleep well at night, or?
Do I sleep well? Not last night. I came from Boston. I got here at 1 o'clock in the morning. 4 o'clock my time. Do I sleep well when I'm worried about this stuff?
I don't know, I mean, just in general, you know, you work security for a long time and you.
Yeah, I'm not, you know, I don't have locks on my doors, you know. I mean, it is what it is. I mean, you just, I look for practical solutions, and the funny thing is, you know, SELinux has its reputation of being really difficult, but SELinux is, the reason SELinux is difficult, tends to, it reveals the complexity of what's going on in the system. Okay, because you're really looking at what processes are doing on the system. And if we don't fully understand what processes are doing on the system, then SELinux can break the application. And if administrators don't understand that. But SELinux can provide incredible power that nothing else, there's nothing in the world that can provide the power that, you know, we're showing there, you know, at least up to this point. So, I mean, there's other technologies coming down the road called, there's a thing called SecComp, which actually would be really neat to add some functionality to OpenShift. What SecComp allows you to do is to eliminate syscalls. So you can basically say, right now you boot up a 64-bit machine that has 600 syscalls on it. Reason is, if you boot up a 32-bit machine, it has 300 syscalls. Any one of those syscalls potentially could reveal a bug in the kernel that you could take over the machine. With SecComp, you'll be able to say, this process from this point on forward is only going to use these 25 syscalls. So now any bug in the other 500 syscalls is gone. So if you think about it, when you boot up a 64, if you build, how many people here still run 32-bit applications on their 64-bit machine? Probably about half, all right? But very few do it. So why do we have those 300 syscalls available to any program that I accidentally download onto my machine? You know, so I could eliminate just by using SecComp. Say I'm not going to run 32-bit applications on my machine, so I can eliminate those syscalls. That's a thing called SecComp that's coming along. But again, it'd be really cool to take SecComp, join it to OpenShift, take a container technology, wrap it all in SELinux, and any other new technologies that come along down the road. So if you follow my blog, I actually blog about new security features that are coming in Fedora. I actually just started my Fedora 19 ones. Everything I did on this is actually being done on Fedora 19, although I almost always am on Rawhide, except I'm going on vacation in 2 weeks, so I don't want to put Rawhide on here. Does everybody know what Rawhide is?
Yeah.
Rawhide's a daily operating system. It usually breaks quite often. So, so that's it. All right.